Hello everyone, I am Prasad from Structural Guide. Today we are going to discuss about the why curing is important and what are the important things connected with the curing of concrete. Let's start our discussions. As we all know, the reaction between cement and water create the concrete. So this reaction is very important for us when we producing the concrete or when we discuss in the concrete. Now as you can see in this figure, I have shown the rebar here and this is the concrete surface. Now the inner rebar I have shown here. So once you pour the concrete, now if this is not covered or cured well, the water or moisture in the concrete will go out. During this process, the concrete in this cover zone does not have adequate water or moisture to react with the cement because the evaporation reduces the moisture or the water content in this zone. So with that, the low strength or low grade concrete will be created here. Now, for example, if we are producing grade 25 concrete, now if the water is evaporated and there is no adequate water to react, in that case the strength in the cover cone may be like 20, grade 20. So we expected grade 25, but 25 is not there, then it would be around 20. So that will be an issue. It will be connecting with the durability. So let's discuss about durability later, but we have to keep in mind this cause durability issues. Now the next thing is, once the water is evaporated very fast, especially in heated environment or when it is very dry, this rate also will be very high. The evaporation of the water from the concrete surface will be very high. With that, shrinkage will come into action. Higher evaporation rate could cause the shrinkage cracks in the concrete. Now these contractions generate the cracks up to the reinforcement or maybe in the concrete surface. There will be cracks like this. Sometimes this crack will develop up to the reinforcement. Now what will happen if that is happen? Now let's discuss about the durability of concrete. Now we have discussed about the low grade of the concrete and the cracking of the concrete due to the evaporation of the water from the concrete surface. So what happened is, now through the cracks, this harmful thing, material like fluoride, sulfate, maybe carbon dioxide will penetrate into the concrete and cause the deterioration of the concrete. Deterioration could be a deterioration of the concrete or else a corrosion of the reinforcement. That's a severe thing that would happen to a structure. If that was happen, then the structural capacity will be reduced. So therefore we have to avoid these cracks and we have to avoid the low strength in the concrete cover zone. Therefore we do the curing. For slabs, we put the water when it starts getting dry, we put the water into the slab surface. In the larger concrete, we cover with the polythene and we put the insulations. Or there are many methods we use in the larger concrete for curing. That you can refer to the structuralguide.com website, or you can see some other videos we have shared in our channel. Next, we will discuss about the thick concrete. How do we handle the curing in thick concrete? Let's discuss about some technical stuff. Temperature gradients. What is the temperature gradients? Temperature gradients is the temperature difference between core and the concrete surface. There will be a temperature difference. Now in the core there will be a high temperature, and when it comes to the surface there will be a certain temperature values. These difference between these two divided by this length is called the temperature gradient. So this temperature gradient we have to maintain at certain level, otherwise the concrete would again get cracks. In general, we maintain this temperature gradient around 20 to 25 Celsius. So that we have to keep in mind. Now when the core temperature is rising, this will also will rise, or this may remain at the ambient level. So that's the one we have to control. Now the core temperature we have to control some other way, and also this temperature at the surface also we have to control, because If this difference is high, then there will be a cracks in the concrete. Another thing is the temperature difference, that is the temperature between the core and the surface. This difference also very important to us, because when the difference is also high, then there will be again issues, and that issues also connected to the cracking of the. Therefore, we have to keep in mind about these things, and we have to control the surface concrete temperature and the inner core concrete inner temperature. Those two we have to keep in mind. And again, another very important thing is the core temperature. As we discussed, we have this will increase with the thickness of the concrete and the type of cement content, type of the cement you use, maybe depending on the water cement ratio, that is called that's connected to the cement content again. Those parameters would cause the increase in the core temperature. When the core temperature is increases, then again there will be a problem. What's the problem we need to tackle? That is the formation of delayed entering gas. When the core temperature, like generally we maintain around 70 Celsius, but if it is increased beyond that, it says, it's not guaranteed, it says there could be a possibility of forming delayed entering gas. So generally we maintain this core temperature around 70 Celsius, but it could go beyond that, of course, but that depend on your specification and all that. As a general norm, we maintain around 70 Celsius. So if that is increasing, that we have to control. Now this, in these things we can handle through the curing of concrete. Now for thick concrete, we don't put the water. So if you put the water temperature in the concrete surface will be varying, because water temperature will be varying. When you put the water here, the temperature of the water will be varied, then the surface temperature may be varying. Therefore we don't put the water, but what we do is we put the insulation here. There may be different methods for doing this, like we put the insulation and we may put the soil on the top of polythene layer. Likewise, there are many methods. You may refer our structuralguide.com website for further information on this also. So that you have to control by some curing method. Again, we have to control the core temperature also. Now core temperature can be controlled through the concrete mix design also. So we are not going to discuss about that today. We are going to discuss about the reducing of the core temperature by curing. So we can place the pipes, or internal piping network can be arranged to reduce the core temperature by extracting the heat in the concrete. With that, this core temperature can be reduced. So that curing method we can use there. So this also kind of a curing method we adapted in construction of very large concrete. So let's move on to the another thing related the curing of concrete, very important thing. Now when we do concreting at cold environment, then we need to have adequate temperature, adequate heat for the hydration process. Now when temperature is very low, like 5 degrees or 10 to 15 degrees, then there will be issue, because there's no adequate heat for the hydration process. The heat will be absorbed by the environmental condition, then that become a problem. There are methods to tackle this also. That's also like infrared curing, increasing the temperature of the reinforcement net. Likewise, there are methods that we can use. Those you may refer in our website, structuralguide.com. We have given many information there, so look into that and study about this. So let's wind up today's discussions. Today's discussion we discuss about the important aspect related to the curing of concrete, why we need to do the curing, and some of the important aspects related to the curing. Especially we discuss about the cover zone stress reductions and cover zone cracking and its connection with the durability and the strength. Again, core temperature, we discuss about the rise of the core temperature and the method of reducing the core temperature and the temperature difference and temperature gradient. All those we discussed today. Let's wind up the session for today. Let's meet again new video. Thank you very much for watching our videos.